Hello everyone. So is my screen visible?
Yes, sir. Visible, sir.
Hi Satvik. Is my audio and the video been seen to you?
Yes, sir.
Okay. So it's a little bit unfortunate that even though there is the time has begun, but there are lot less participants. But the good thing is that this will be uploaded to the YouTube channel, so you can access the video later on also. So there's no issue in that. And anyways, during the talk, we will actually have a long talk. And during the talk, you can ask me any question, any doubts that you have. So feel free. You can stop me in between and you can ask me. Right? So, okay, then. So my slides are visible, right?
Yes, sir, it is visible.
Okay, okay, okay. So, so my name is Tanmay Sharma. I'm a Prime Minister Research Fellow from Mechanical Engineering Department, IIT Patna, and I am selected as a tutor in this course, IC Engines and Gas Turbines, the NPTEL course. And today in this session, I will be introducing you to IC engines with some videos, with some exciting videos that I have collected throughout. So already you have gone through the course in NPTEL website, and you may have attended two lectures. So you are already introduced to ice engines, but there may not be videos available there, and you may have some confusions regarding how actually the ice engines are working. So that will be cleared in this session. So basically, the topics I will be covering in this session is that I will be introducing to you the heat engine and what are the major different types. That is the internal, the external combustion engine. So I'll be explaining you those, and we will see their applications, and we will also see exciting videos of the applications I have collected through YouTube channels. And then we will come back to the internal combustion engines, which is the main focus of this course, and see how these are classified. So we'll get to know what are the different cylinder arrangements, what is four stroke, what is two stroke engines, about the methods of ignitions, and I have collected videos for these cases also. So you will get to learn how these are working in real life. And finally, we will end the session with a few sample problems, which will help you in the solving the tutorial, this assignments, right? So let's move on quickly. Um, yeah, let's So heat engine. So heat engine is a device which operates between two temperature differences and can be either for use for producing power by absorbing the heat energy, or transfer heat from low to high temperature by absorbing the power. So you can see that this is the source. Suppose we have a source of high temperature, a sink of low temperature. Then if the energy is supplied to this engine, and there will be some useful work in compensation of some energy which is rejected to the sink. So that is called as a heat engine. Um, and there is another type of the heat engine, that is refrigerators. So in that, what we do is that we give power to the engine, and it will transfer the heat from the lower temperature sink to the higher temperature. So that is what we are having in our fridges, refrigerators, or air conditioners. So this is the schematic diagram of how a power producing heat engine is working, and we will be focusing on this. Then the classification of heat engines in broader terms is basically, first is the power producing and the power absorbing, which is basically the air compressor or the refrigerators, but we will not go into this section. Rather, we will focus on power producing, and we will go to internal combustion, both reciprocating type as well as the rotary type. So the in reciprocating type, we will have the spark ignition and the compression ignition engines. So we'll focus on that. And towards the end of this course, we will focus on the gas turbines, which is basically the rotary type, but it is also under the internal combustion engines. But there are other classification of the power producing, like the air motors and the external combustion engines. I would suggest you go through these in online, then you will get to know about this. And I will show you in today's session itself that a few of the external combustion engines, such as the steam turbines. And I will be basically following the book, The Internal Combustion Engines by R.K. Rajput, and they have a very good number of sample problems that you can solve, and you can get your confusions out. So you can follow this book. Then, so what is the difference between the external combustion engine and the internal combustion engine? Basically, the combustion is not enclosed in a closed volume inside the engine. So if the combustion is not enclosed, it is happening somewhere outside, there where, and it is being, the heat is being transferred to the gases which is circulated in a closed loop. Then such kind of engines are called as the external combustion engine. So you can see this is the coal boilers in huge ships. So in huge ships, they will have a boilers, and they will burn the coal out there, and the heat energy from here are circulated, are transferred to a loop where the gases are flowing, and accordingly these gases will go to the turbine, it will rotate the turbine, and the power is produced. But internal combustion engine, the combustion is enclosed inside a closed volume. So wherever these gases are coming, and there itself the combustion is happening. So these kind of engines are actually the internal combustion engines. So such as in cars. So you can see here that the combustion, the gases are transferred to this particular cylinder which is enclosed, and here the combustion takes place, and this is called as the internal combustion engine. So we'll go into depths, but first let us see a major differences between these. So first of all, in the external combustion engine, the main advantage is that the fuel use can be solid fuel such as coal. So you must be knowing that we do not use coal in cars, right? But again, solid fuels, we need to utilize that particular resource of energy. So where can we utilize that? Also, we need to have a combustion engine. So that can be utilized in externally firing this coal and transferring the heat to another system. So that is the advantage. And here the fuel used are liquid fuels like petrol, diesel, or gaseous fuel like CNG right now. So these are the fuels used here. Then the supply of oxygen. You must be knowing that for combustion to take place, you will have to supply oxygen. So oxygen is generally passed by creating a draft through a chimney, or by near a burning grid. So you will have huge chimneys in the this industries, and there the oxygen is being circulated. So the oxygen will be circulated through this grid, and then it will pass through, and the combustion will take place. But here the oxygen is passed along with the charge, along with the fuel. So again, there is a classification how the oxygen and the fuel is being passed, but you can see this oxygen is supplied internally. So that's why the internal combustion engine. Then we based on the applications, generally have these machineries, these external combustion engines are quite heavy, and these are not used in small transport vehicles. But also there's a catch. So the external combustion engines are used in huge steam this where the steam turbines are used in huge ships. So in internal combustion engine, these are lightweight and can be convenient for transport. That's why we use in cars. And but although these are lightweight and convenient for transport, that doesn't mean that they are not used in big commercial vehicles like ships. So I will show you these videos and you will get to know better. Then these are generally used for producing electricity in large scale. So in industries, you will have turbines and everything. So boilers. So in the boilers, they're using the coals, the water is boiled, and again the steam produced is used for rotating the turbine. So that way the electricity is produced in large scales. But these are not generally used for producing electricity in large scale. Rather, it is just for the transport. So that's the major differences between internal combustion engines. Now, moving on, the advantages of external combustion engine is that the starting torque is generally very high. So while when this engine has started, so initially you will get a very huge force which is not available in case of internal combustion engine. And because the combustion of fuel is external, the cheaper fuels like solid fuels or coal can be used. Then due to external combustion, it is possible to have flexibility in design. So you are generally transferring the heat from one point to the other point, right? So that's why you can place your grit, the burning grit, somewhere, and you can somehow transfer the heat energy to the loop which is placed somewhere else. So that's how you can have a flexibility in design. But in internal combustion engine, you cannot have that. You will have to have a very compact system and very sophisticated system. Then these units are self-starting with working fluids, such as in case of so in IC engine generally we have an additional system like the ignition system which ignites it, and you will also face that during the cold season. So your cars does not start automatically. So it will take some time. So the engine has to get heated up, and after that only you can start the system. But these the external combustion engine, you will simply have to yeah, although it is time taking, but you will simply have to ignite the fuel, and after that the working fluid when it is in optimal temperature, has reached into optimal temperature, you can simply start the whole system like the turbines in the engines, sorry, in the industries. So that is not possible in the IC engine. So in IC engine, although the starting ignition is quick, but yeah, the in you will have to wait for some time for the engine to get heated up during the cold weathers. So the application of external combustion engine is large ships, hot air engines, steam turbines, gas turbines. Okay, the gas turbines here, there are some externally combustion takes place somewhere. So these are the gas turbines which I'm talking about. But mainly the gas turbines are classified into internal combustion engines. Then steam locomotives, I will show you the picture of the steam locomotives. Then internal combustion engine, yeah, the main advantages is that although it is very compact and sophisticated, but the overall efficiency is quite high. Then it has greater mechanical simplicity. Weight to power ratio is generally low. So that's the main case why internal combustion is used in transport vehicle. So you need lower weight, and in the lower weight you need higher power, and that is only possible with internal combustion. You cannot expect that from external combustion because it needs a huge space. The machineries that are used are quite heavy, so that way the weight to power ratio is generally low in case of internal, but here it is quite high, and it is economically not favorable to use it in transport vehicles. Then the lower initial cost. So that but although the initial cost is low, and here the initial cost to set up the whole system is quite high, but the maintenance and the running cost in the internal combustion engine are also quite means comparable to both these cases. I am not saying that this is quite low in this case, but yeah, these are comparable. So the the initial cost is generally low in internal combustion engines. Then easy starting from cold conditions by using. So today in this course later on you will get to know that although the ignition system is used, but there are certain systems provided inside the engine to keep the engine warm. So the when the engine is kept warm, what happens is that you will not have to face difficulty while starting the engine. So while you must be seeing that while starting engine cold systems, it does not uh, quickly start. But using these external devices like some heaters in the engine, so that way you can keep the engine warm, and accordingly you can start without any problem. So now these kinds of systems are also used in internal combustion engine in order to get rid of the drawbacks. So again, we know that, and these units are compact, and the applications includes light and heavy motor vehicles, boats and ships, airplanes and trains. So this is an example of the external combustion engine, the marine steam engine, where the steam produced is used to rotate the turbines. And this is a video, and have a quick look at this video how it is happening. So here it is the boiler room where the coal and the solid fuel are burned, and heat energy is produced, which is actually produce the steam. You can see how big it is. So basically, the main steam paper is draft steam gases into the boiler, and the solid gas that is ready in the machine. So here is the pipe connected to the boiler where it can easily supply the steam in a very optimal way. So this pipe connected to the boiler. So the pipe is connected and just in the direction of the compressor, the gas is being floated. So you can see how big it is. So the pressure is becoming like double of the floating. So this electrical line here runs with the chemical reaction, which produce refining enzymes in the steam. Now, we can go back to uh, the cabin where we have the moving forward. So basically, you have learned that how external combustion engine, especially in the main steam engine, it works. But in main diesel engine, which is also used to run the ships of big high scale, so there also internal combustion engine can be used. So this is an interesting video which can set the contrast between external combustion in the same type of transportation, that is ships, right? So this is a video playing for that, and this is the main diesel engine. So diesel, and the air it makes the and inside the combustion chamber, and it burns, and this is a compact system. Here you do not have any burning grid or boilers, so you see how it is different from the external combustion engine.
Marine engines are considered to be the biggest engines on Earth
You can see the
with massive
comparability track
power
engine.
to propel a heavy loaded ship. There are different parts of the marine engine which helps the engine to rotate the crankshaft and propel the ship from one port to another. Each component plays an important role in powering and running a marine diesel engine. But the engine cannot run unless all components are in place and are in working condition. The main engine of a sea-going cargo ships are usually two-stroke internal combustion engines.
So we'll get to
The
learn
working
about
of the
this.
two-stroke engine can be understood from this video.
Also, you
For
can
a
go to
marine
their
engineer
videos.
or a professional working on ships, it is vital to know different engine parts and their function to operate and troubleshoot when needed. You must have seen the engine inside the machinery room of the ship, covered and assembled with different other auxiliaries. Let's take it out from its installation
So
and
this is
only
the whole engine,
concentrate on the main
although
engine
it has
to
three
understand
floors.
its different parts.
So that was the internal combustion main diesel engine, and in contrast to external combustion main steam engine, you will see that it occupies a little lesser space. There is no requirement of a burning grid to burn coals or solid fuels, and produce steam to rotate the crankshaft. That is not required. But here, the only thing it is required is diesel. So diesel and air, so when it is mixed inside the combustion chamber, so it is not mixed outside. And finally, you will find the due to the combustion, the forces are acting on the piston, which you will learn later, and it will rotate the crankshaft. So that's the entire thing, external and internal combustion engine. You can have a look at these videos later in the YouTube channels. So we will come back to internal combustion engines, which is actually the main focus of this entire NPTEL session. So yeah, internal combustion engine, there can be reciprocating type, there can be rotary type. So we will learn about both. In the reciprocating type, so reciprocating type means to and fro of the piston. So that is reciprocating, but eventually the energy is rotating. So, but in the rotary type, the gas turbines, that is not to and fro. It is basically the engine is completely rotating, and that force produced is directly used in rotating the crankshaft, not through a piston and connecting rod. So we'll get to know about all these things, but first of all, we will concentrate on internal combustion engines, and we will see how these are classified and what are the different types. So the combustion is enclosed in a closed volume inside the engine that we know by now. So basically, in an internal combustion engine, we will have this particular kind of an idea that this is the internal combustion engine. Although this is not exactly how it looks, it is a little bit more complicated, but this is an idea. So what we will have is that this black dashed line is basically the outer covering. So you need not worry about that. But this is the piston out here. The combustion happens above the piston where it is having a closed volume, and this is the cylinder in which the piston moves to and fro. That is the reciprocating action. And then we have the gudgeon pin by which this connecting rod is attached to the piston, and finally this connecting rod is also attached to the crank, and we will have the crank rotating in circular motion. So you will find this is actually how it basically looks, but here, due to the we haven't yet specified which type of internal combustion, that is the spark ignition or the fuel injection, because there is another component to be added out here. But this is the general idea. We will take care of the combustion later, but this is the general idea of an internal combustion engine. The basic idea is to get the combustion inside the cylinder, but how to do that, we will come to it later. So this is where the piston is moving to and fro, and accordingly the connecting rod is transmitting this reciprocating action into the circular motion, and accordingly we will have a circular action of the crankshaft. And there is a flywheel out here. The need of a flywheel is that the strokes, when we talk about the strokes, so the strokes means one coming up, the piston coming up or piston coming down. That is one stroke. Coming up is one stroke, coming down is one stroke. These are strokes. And during the strokes, only one in four strokes is generating power in a four-stroke engine, and one out of two is generating power in two-stroke engine. We will learn about this. And accordingly, there is an unevenness in the power in the entire cycle. So that's why to even out these powers, so the flywheel will take up a huge amount of energy when the power stroke is being performed, and accordingly it will release in other strokes where the power is not produced. So this is the reason why flywheel is used, and you will get to know about it later. So the other components have the exhaust valve. This is the exhaust valve and the inlet valve out here. The inlet port where either the air or the air fuel mixture is passed. So we'll get to know which is passed in which kind of engines. Then we'll have this cooling fins. The cooling fins actually are provided to cool down the engine. So when the combustion takes place, it is a huge pressure and temperature, and not all the pressure and temperature are utilized to drive this crankshaft. So eventually, some amount is absorbed into this metallic bodies, and it will get heated up. And we need to cool that also. So we have the cooling fins and the cooling jacket also. This is the cooling jacket. So the that is the cooling part, and the other thing is the oil ring. So the oil ring is you will see that due to the reciprocating action of the piston, generally it slides over this cylinder walls, and accordingly due to friction it can wear out, right? So just to avoid the wear out and also provide a seal for this combustion materials to not flow out and just combust out into this enclosed volume. So we have oil rings in here. So this black color marks you will see, these are basically the oil rings. And the oil rings provides a seal. It does not it prevents the leak, and also it provides a heat transfer between these two. So the metal and the cylinder metallic part and the piston surface, these are connected through the oil rings, and these are lubricated. So lubrication is another concept we will learn in this NPTEL course, so that's for another time. So that's the whole thing, or the basic idea of an internal combustion engine. Now we will get to the classification of different types. So the classification of different types are, so we learned about the engine components, but we will talk about based on the engine components how these can be classified. So the based on the cycle of operation, there can be two-stroke cycle or the four-stroke cycle engines, and we will get to need not worry, we will get to know each and everything based on the cycle of combustion, the Otto cycle engine, diesel cycle engine, dual or semi-diesel cycle engine. Then based on cylinder arrangement, we'll have single cylinder, inline or straight, then V engine, W engine. So opposed cylinder, opposed piston, and radial engine. And I have found videos, quite interesting videos, to demonstrate how each of these are working, how the cylinder arrangement are making a big difference. Then, according to method of ignition, we know by now the spark ignition and the compression ignition engine. Then, according to users, there's the stationary, marine, aero engine, portable, automobile. According to the speed of the engine, the low speed engine, medium speed or high speed. So, according to the method of cooling, air cooled and water cooled. Quick thing, air cooled, you will see in the motorcycles generally the engine is designed in such a way that the air is allowed to pass through the engine, and accordingly it takes away the heat that is produced in the cylinder walls. So, heat in the cylinder walls is actually caused due to the combustion inside the engine. So the motorcycles are generally having the air cooled engine, but in the cars, four-wheelers, generally that is not the case. There is a radiator arrangement and the completely separate cooling system, and for there the water cooled engine is produced. So there will be a water jacket covering the entire cylinder, and the water which is getting heated up, it is eventually cooled by the air passing in the radiator. So we'll get to know about all this. Then method of governing. So why we need to govern? So you know that the fuel is quite costly nowadays, right? We need to conserve the fuel, and we need not use a large amount of fuel where it is not actually needed. The power we can conserve, and to have a very required amount of fuel supplied to the engine cylinders for combustion, there is the governing system, and it governs the rate of the amount of fuel needed in whichever cases. Suppose for example, you are riding a bike, and you are the only person sitting on the bike, so the to maintain a particular speed, you need not get too much of this fuel into the combustion system. But if there is another person riding behind you in the same bike, so then to maintain a particular speed, the more amount of fuel will be required. So that particular thing is being governed by governors. And there are types like a hit and miss govern engine, quality govern, quantity govern, and the governing, I think it will be covered in this scheduled machines classes. So that is may not be a part of the NPTEL course, but let us see. If needed, I will also demonstrate here. Then, according to the valve arrangement, the overhead valve engine, L head type, E head type, and F head type. So the valves are actually present to take in and take out the combustible mixture. So that is used to supply the combustible mixture inside the combustion chamber. So based on that also you can have the classification. And finally, due to the number of cylinders, that is the single cylinder multi-cylinder engine. So you must be knowing all this. Obviously all of our are now expert because we are the already riding our own scooty or bikes, right? Or even cars. So we have a basic understanding of what are these. Anyways, you can always refer to the internal combustion engines book by R.K. Rajput, and there are other books also. So you can refer and get by all this. Then we will talk about based on the cylinder arrangement. So cylinder arrangement can be classified in differently, like the single cylinder, which is basically in many of the motorcycles they use single cylinder arrangement, but nowadays multi cylinders are also coming. And then we have the V type engine. So V engine is basically used in railway locomotives. So big locomotives in the trains that you see are actually V16 or V20 engines. So V16 means there are 16 cylinders arranged in V shapes, and these are very huge engines. And basically this is how they function, the V-type engine functions. So the overall thing is that you will have to rotate the crankshaft in a circular motion, and how to do that, that is based on this. So inline cannot work, or a straight arrangement is not working in case of this locomotives because of the space constraint. You cannot have a big locomotive occupying a huge space. So that's why to reduce it, you will have to make it compact, and the V type is the most suitable in this kind of things. So that was how this worked. And then we have the inline or normal cars, like I told you in a video before, in the steam turbine or the this main diesel or main steam engines. So there you saw the piston cylinder arrangements in this fashion, right? So that was inline or straight. So in normal cars also you will find these kind of arrangements, and this is how it works. So so you see how this is working, and you saw a similar thing in the previous case also, previous steam mains engines, and this is inline or straight. Then we have the opposed cylinder. So the interesting thing is that in the opposed cylinder, the cylinders are in a straight line, and the pistons are facing opposite to each other. So the crankshaft is in the between, and accordingly the combustion will take place in the two ends of the cylinders. This is the one cylinder, this is the second cylinder. The ends of the cylinders, the combustion will occur, and accordingly the piston will have a reciprocating action, and it will be transmitted to circular action by the connecting rod. And this is how it basically works. You see, finally, it is rotating the shaft in circular motion by the reciprocating action of these opposed cylinders. So this is opposed cylinders flat 4-cylinder arrangement because we have 4 pistons. So you can see now. Again, if there is any question, you can stop me and ask. There is no point of hesitation. This is a formal, you can call it, it's a formal session, but still you can ask in between. You can stop me anytime. Anyways, am I audible?
Yes, sir.
Uh, yeah, am I audible, right?
Yes, sir. Sir, I
Okay.
have doubt, sir.
Yeah, please.
How how these models will increase the efficiency of the engine?
That's a good thing. So efficiency of an engine is basically you will talk about we will talk about this in later sessions. But if you talk about this efficiency of engine is based on the engine diameters and the engine stroke length and the rate at which this everything is the combustible matters and everything is coming. So it will depend on that, and we have derived how this efficiency is means in form of a mathematical equation. So you will get to know about this later. But right now, the main point would be how to have the maximum efficiency for a particular system which is convenient through that system. In that way, if you think you cannot use one cylinder arrangement in everything to increase the same amount of efficiency. So you will have to compromise between your designs. So somewhere in V-type engine, the this in locomotives, you cannot have such kind of opposed cylinder arrangements. But although you will need to have the same efficiency, right? So that way they are optimizing everything. But to answer to your questions, actually this everything depends on the piston cylinder this measurements, and you will get to know the exact formula by which you can measure these efficiencies or the net work produced. So the efficiency is basically how much work is produced against how much energy is supplied, right? So these are having different equations, so you will get to know about this later. Is this okay for you
Okay.
now?
Yes, sir. Okay, sir.
Sure, sure. Then moving on, we have W engine, W shaped. As you can see, this is a W, but exactly how it looks, I will show you in the engine of a Bugatti Chiron. So you must have known Bugatti Chiron and Bugatti Veyron. These are super fast model cars, right? So there they use W16 engine, and this is a demonstration of how these are working. So this is a Bugatti Veyron or Chiron engine, and you see the W type. This is not exactly V type; it is W. So this is one thing, and the piston here it is coming in between the spaces of these two. Although these are joined separately in the crankshaft. So this is how a W16 engine, 16Y16, because their total numbers of cylinders are 16. So like that, it is being numbered, and these are being used accordingly. Then we have the opposed piston. So since we had the opposed cylinder, it is also possible to have an opposed piston cylinder arrangement. So you will have only one cylinder in there, and there will be two pistons, and the ignition will take place somewhere in between. And accordingly, this piston will go ahead, go apart, and will have a reciprocating motion, and there will be two crankshafts attached out here. And accordingly, this will rotate the two crankshafts. So from one combustion, you are having two rotations of the crankshaft. That's the advantage, and you will see this.
You've probably never seen an engine like this, despite the technology being over a century old. Opposed piston engines, like this one by Acades Power, operate similarly to two-stroke engines. When the pistons reach their respective bottoms, fresh air flows in from ports at the bottom, while exhaust is rejected through ports at the top. That fresh air is squeezed in a small pocket in the center of the cylinder as both pistons come together, where finally diesel fuel is directly injected, igniting the mixture and creating the power stroke. This pushes the pistons out, and the cycle repeats itself. This all results in an engine that is small, power dense, and quite efficient. So why don't we see these used in production cars? Is it because electric cars just make more sense? For a different opinion,
So again, if you have any doubts, you can go to this YouTube video and you can really connect with them. It's a great way of exchanging the knowledge, and I have shared the link in here, so you can connect with them. You can have the comments and you can ask where and how these are useful and fruitful, and which type of engine we should select for this kind of situations, right? There are a lot of situations. Not only the cars is one of the problem, but even if we talk about diesel, this generators and everything, so we will have to know how to use these kind of engines out there. So these are based on the cylinder arrangement, and the last one is the radial engine, where this is used in an aircraft engine, and that is quite interesting to know how an aircraft also uses radial engine, and this is a demonstration. So you must have seen that there is no combustion working out here right now. So that is not the case. The combustion is not working out here, but this is rotating because of the rotation induced by him at the crankshaft. So obviously, so he is demonstrating how this engine works. But instead of rotating this crankshaft, if the combustion also happens at regular intervals, the firing order should be quite precise. Then you will find this kind of similar motion. So that's how an aircraft engine also works. This is the front of the propeller in an aircraft engine. But again, nowadays, in commercial flights over long distance flights, this kind of arrangement is not used. We have jet engines, and the prop engines are quite are means this kind of engines are only used in smaller aircrafts, for like the aircrafts which are used to supply the chemical fertilizers to a fields, farming fields. So those kind of aircrafts are using this radial engine. So that was the all the cylinder arrangement, how we can classify the engine based on cylinder arrangements. So next we will be knowing about different kind of this based on the ignition system. So based on the ignition system, not only four-stroke engines have either SI, that is spark ignition, or CI, that is combustion engine, ignition engine. We have for the similar thing for two-stroke engines as well. So although this is quite the diagram that I am showing here is for a four-stroke engine, that's why I'm writing out here. But please keep it in mind, a two-stroke engine can also have a spark ignition and a combustion ignition, because the ignition is not dependent upon what how many strokes you need. So that is quite independent in nature. So the basic idea is, so if this is a basic model of the IC engine, where we need a combustion happening just above the piston out here, and there is an inlet and the exhaust valve, the inlet valve supplying the air fuel mixture out here, or the simply the air out here. So we will need a mechanism to somehow produce a combustion or ignite this whole thing. So based on that, the there are the ignition system out here, the spark ignition and the compression ignition. Again, the spark ignition and the compression ignition, nowadays you will find there's a lot of other methods to finally get the ignition done out there, and even to adjust for the efficiencies, you will have to account for the efficiency, and accordingly uh, these methods can be found in both the cases. So for talking in a very broad term, there are two classifications of the ignition system, that is a spark ignition and the compression ignition. In spark ignition, we use a spark plug to ignite the whole combustion mixture out here. So basically, you will have an air plus fuel mixture coming through the inlet valve and entering into this combustion chamber. Please mind that is air plus fuel. So the fuel is already supplied to the inlet valve, and this charge is ignited by a spark plug. The spark plug, what it do is that it creates a spark, and due to the properties of this charge, it will ignite, and it will catch a fire and it will ignite, and accordingly when it ignites, the liquid part, the volume suddenly increases, and sudden increase of the volume actually creates a pressure because we are not letting the volume increase. So that's how it is creating a pressure on this piston head, and eventually it is accounting for the reciprocating motion. Whereas in a compression ignition engine, only the air is supplied through this inlet valve, and the fuel is separately injected into this combustion volume. The advantage here is that the two fuels used in these two cases are different. The fuel out here is injected in a very high pressure and temperatures condition. So when it is very high pressure and temperature condition, the fuel injected automatically so it is injected not in liquid drops that you can see, it is actually mist, very minute drops. So that is also called as a process atomization. So atomization is quite important while you inject a fuel inside this chamber. And when it atomizes, it due to very small volume of the droplets, fuel droplets, the area of this small volume are quite high. When so a very small volume actually has a combined surface area will be quite high, and accordingly in this surfaces the ignition will quickly start. So yeah, so it is not injected in small these drops in form of drops that you can see by your own eye, but in types of mist, which is very small droplets, and accordingly the surface to volume ratio, surface area to volume ratio, it increases, and accordingly when it mixes with the air is always needed. The oxygen we will need to ignite, and it will, due to the high pressure and temperature, it will quickly ignite, and it will catch the fire, and the accordingly the volume will increase, but not letting the volume increase will increase the pressure, and accordingly we will have a force acting on this piston. So that's the case between compression ignition and spark ignition. And there's one more thing to note: in the spark ignition, the air and fuel is mixed in a carburetor in the required amount, and then the mixture is sent into this chamber. So this is the basic difference. The spark plug is used to ignite the fuel, whereas the fuel is ignited at a high pressure and temperature inside the cylinder. The compression ratio, we will talk about this. Compression ratio, that is the uh, how much means it should compress. It basically signifies how much it should compress the this mixture. It is quite less in this because we are using external means to ignite. But here the compress, how much it should compress the mixture, it should be quite high to create this high pressure and temperature in order to have means the combustion taking place. Because the compression ratio is quite low, it lesser cooling requirements are uh, needed here. But here higher cooling requirements are needed because the pressure and the temperature is quite high, and you need to cool this system and avoid the burning, melting of this cylinder. Then again, fuel is supplied from the carburetor and fuel is supplied from the injector out here. This is used for generally high speeds, and this is used for low speeds. And for high speeds, actually, you will see that the system is quite lightweight in this spark ignition because the temperature and pressure inside is quite low in comparison to this. Because of high pressure and temperature, in order to withstand that high pressure and temperature, this system needs to be quite bulky, otherwise it will break, right? So this system is made quite bulky, and in the way of making it bulky, the it becomes of higher weight, and accordingly the thermal efficiencies means this varies. The thermal efficiencies here, because the thermal efficiency is dependent upon the compression ratio, we will get to know about it later. It has quite high thermal efficiency because of high compression ratios, whereas this has lower thermal efficiencies. And one thing to note, due to the high speeds and low speeds, the high speeds are required where? In the F1 cars and everything. So there the spark ignition engine is used, and whereas this cannot be used because the weight is itself quite high, and you cannot have high weight in a very high speed condition. So that's the case between the method of ignition. Also, I'm audible, right?
Yes, sir.
Yes, sir.
Audible, sir.
Yeah, so seeing uh, the comparison between ignition methods, and we will get to know about this later also, how these ignitions are happening. And this is the whole motive of this NPTEL course on IC engine and gas turbine, to know how the ignition is happening and each and everything to the detail, so that you need not worry about it. This is just an introduction to these IC engines. So next thing, we will get a little bit more into depth how the spark ignition engine actually is working. So this is a schematic of this is the schematic of the four-stroke spark ignition engine. So four-stroke why? So you will see four times this piston is moving up and down, right? So this is one stroke coming down from, this is the top dead center and this is the bottom dead center. The top dead and the bottom dead center basically signifies the from which point to which point the piston will move. And the piston, when it moves from top dead to bottom dead and again come up, again goes down and again come up, so there is four times it is executing the stroke, and accordingly it is a four-stroke engine. And why spark ignition? Because there is a spark plug out here at the top, which is creating the ignition, it is causing the ignition. That's why the combustible gases ignite, and accordingly it creates the power stroke or the working stroke. So this is quite important, the working stroke or the power stroke. So, and we will learn about these strokes. So what happens in a spark ignition engine is that, first of all, let us assume that this piston is at the uppermost top dead center. So this is, if this is the top dead center, this is at the uppermost position. And now the in the volume above, there's only exhaust gases or combustion gases which will remain from the previous cycle. So, and that is already, it has left through the exhaust valve, but there may be some amount remaining still. And what it has to do is that it will have to get in new combustible materials, and that air fuel mixture, which is again supplied by a carburetor, if it is mixing the air and fuel in the right amounts, and it is supplying it to the combustion chamber. So that air fuel mixture is sucked, it is sorry, it is sucked inside the the combustion chamber, and that is being sucked in as in the stroke, suction stroke. So in the suction stroke, the air fuel mixture is coming inside. And why will it come inside? Because the it is lowering, as it is increasing the volume, suddenly it is lowering the pressure out here than the atmospheric pressure, and this pressure difference is driving the air fuel mixture into this system. And when the airflow mixture is completely present out here, this inlet valve will now close. When the inlet valve will close, and also the exhaust valve will close, and eventually now the compression will begin, as the piston will again move from the bottom dead center to the top dead center, and the volume will decrease accordingly, the pressure is increasing. So this is actually compressing the whole airflow mixture out here, and that is called as the compression stroke. Eventually, the at the last end of the compression, there will be huge pressure and this at low volume, and at this condition, the spark plug will create a spark and it will ignite the whole combustible mixture. And due to the combustion, suddenly the airful mixture, the liquid quantity will vaporize into gaseous quantity, and the volume will suddenly increase. And this sudden increase in volume, while the volume is kept constant, is increasing basically the pressure in this system. The pressure is quite getting higher and higher as the all the fuel is being burnt into gaseous state, and that pressure is basically pushing the piston down, and it is creating a force out here. And eventually the piston will move from the top dead center to the bottom dead center, and the whole of the gases are now completely uh, means in vapors, gaseous state. All the charge is in the gaseous state, and it has pushed this piston from top dead to bottom dead and creating a work. So this is the pushing in this pushing action, it is imparting a work from the heat energy produced out here. So heat energy to work energy is being converted in this particular stroke, hence it is called as the working stroke. And when the working stroke is completed, when the piston is at the bottom, it has now eject the combustible gases because it is no longer of use, and it will eject the system out through the exhaust valve. It will open, the exhaust valve will open, the inlet valve still closed, and the exhaust gas will go out, or the combustible gases will go out. This is called as the exhaust stroke. So you will see that in four strokes, four up and down motions of the piston, two coming down and two coming up, four strokes. Accordingly, in four strokes, only one stroke is creating the work needed to rotate the crankshaft, right? So this is the working stroke. And so now if the question comes that if working stroke, we are concerned only about the working stroke, and suppose the revolutions per minute of the cylinder is n, suppose n. Okay, so n revolutions in 1 minute it is completing. So within n revolutions in 1 minute, how many times the working stroke is completed? So in order to answer this kind of questions, you will have to first see how many cycles, means how many cycles it is completing. So in four strokes engines, basically two cycles complete one, two rotations of the crankshaft completes one cycle, right? So here it was at the starting case, it rotated once, and it ended the compression stroke. Again, from here it again rotates in here, and from here it comes back here. So two rotations are completed in one cycle, and two rotations it is having only one working stroke. So if there are n rotations per minute, there will be half n, or n by 2 walking strokes per minute. So that's how you will have to figure out for basis of 4 stroke and 2 stroke engine. If the question comes like how many walking strokes are present in this amount of rotations, so this is how you will have to figure out that. And this is basically the pressure versus volume diagram. So eventually you will see in the suction. So due to the lower atmospheric pressure developed inside the chamber, it is from 5 to 1, it is going out here. This is atmospheric line, and it is lower than the atmospheric line. Eventually this is now compressing it, so the pressure and the volume will decrease. Eventually the pressure will increase, and accordingly it will go from 1 to 2 out here. And after that, the compression, at the end of the compression, the working stroke will start, and the spark plug will ignite at the end of the compression. Accordingly, suddenly a huge amount of pressure is created at very less infinitesimally small change in volume. Okay, so that way 2 to 3 is the rise in pressure at the end of the working this compression stroke. And after that, when the compression stroke working stroke resumes and it goes down, eventually it will now expand like this. The volume is increasing, whereas the pressure is also decreasing, and eventually it will land up to 4, and from 4 again the exhaust stroke will go. So the here the pressure should be a little bit higher than the atmospheric line in order to push the combustible gases away from the exhaust valve. So the this line is like this. So that's how the PV diagram looks. But if we exactly need the to calculate the theoretical efficiencies of a particular system, then we will have to consider very sharp points at these. So this is called air standard cycle, and we will talk about that in my next session, as well as in the next week's videos uploaded in the NPTEL website. So these are the air standard cycles and why we need them. It will be quite explained in there by sir. And eventually we will look at these systems to finally get a value of the theoretical efficiencies that we can expect from this kind of system. So you will see that this is constant volume process, right? 2 to 3 constant volume process. So that's why in spark ignition engine, which actually follows Otto cycle, it's a constant volume heat addition process, or heat addition cycle, constant volume. So that's about the spark ignition.
How
And
four-stroke gasoline engines work.
this is the
Four-stroke
video.
gasoline
Have a look.
engines use 4 strokes of a piston to complete one combustion cycle. The 4 strokes are intake stroke. The piston moves down, drawing air into the cylinder via the air intake valves. Compression stroke. The piston moves up, compressing the air within the cylinder. Power stroke. Fuel is injected, and a spark plug ignites the air-fuel mixture, causing a controlled explosion. The expanding gases force the piston downwards. Exhaust stroke. The piston moves up, forcing the exhaust gases out of the cylinder via the exhaust gas valves. The 4 strokes repeat themselves over and over again, generating power, then transferring it to the load. Subscribe to our YouTube channel to learn more about engineering.
So really the YouTube channel, Savri 3D, you will find exciting videos like this, and you can follow their channel. So this is I have used their video for explaining you here, but you can go back and you can find this video there. Then let us come to combustion ignition engine. So this is where the fuel, most commonly the diesel fuel is used. You must be all knowing that. And what happens is that the basic difference between the combustion and the previously spark ignition is that the presence of a fuel injector in place of a spark plug. So what happens is that the strokes are completely the same: suction, compression, working stroke, and exhaust stroke. These are completely the same, but the method of ignition is different. So here the fuel injector, when the compression stroke executes and it reaches at the end of the compression stroke, the fuel injector supplies a very precise amount of fuel inside the combustion chamber, provided this inlet and the exhaust valves are closed, and accordingly this will uh, ignite automatically because of its chemical and physical properties and the huge pressure and temperature inside the system. And due to this combustion taking place, it will combust, and all the gases formed inside will push the piston downwards, and the working stroke will happen. And at the end, the exhaust stroke is completely same as the spark ignition engine. So that's the only difference is that the fuel is injected directly into the system, but in spark ignition, air fuel mixture was introduced into the system, and the air fuel mixture was mixed at a very right amounts by a carburetor. But nowadays, the carburetor is completely absolute. It is being removed from the system, tried to remove from the system because it is being a little bit bulky in nature. So there, what happens is that suppose we have a inlet manifold in a spark ignition engine, so they will directly inject the this fuel in the inlet manifold, but not into this chamber, but outside the chamber into the intake manifold, and there the air fuel mixture will be formed, and it will eventually go inside the system. But that is again for let us restrain to only this part. We will talk about that in a later conversation. So this was the combustion ignition engine strokes, and this is the PV diagram for those strokes, the actual PV diagram. So what happens is that initially at the beginning of the suction stroke, so it will have to reduce the pressure in order to take the air inside, only air, not air fuel mixture. So this is the suction stroke where it takes the air inside, and due to the atmospheric pressure difference, due to the vacuum created out here, it the air enters inside, and at the end it starts to compress the air, only the air in the compression stroke, and accordingly you will have a rise in pressure and a decrease in volume, and also an increase in temperature of the air. And eventually you will find at the just at the end of the compression stroke, the fuel will be injected, and you will find a pressure, a constant pressure will be maintained out here, because the fuel takes some time to completely mix with the air, atomize, and it will it will get vaporized into the gaseous components. So it will take some time. So in that time, the piston is already moving downwards. The volume is already increasing. So our net amount of pressure which is built up here and the volume which is also increasing is responsible for a almost constant pressure like action out here. So that is the big difference. So in spark ignition, automatically everything will ignite at a very large pace, and it will create a huge pressure built up. But here the pressure remains almost constant because the although the gaseous components are being formed in this combustible region, still to accommodate the gaseous components, the piston is also moving downwards. So there is no increase in the pressure, almost very small increase in the pressure, and accordingly, this part will be seen 2 to 3. And finally, when the working stroke resumes and it is coming, the piston is coming down, it will expand the gas, and at the end, it will have a exhaust stop. So that's why theoretically, if we see, then the pressure always remains constant from 2 to 3 out here. And the reason behind is that when the gases are being formed or the fuel is vaporized into the gaseous components, the amount of increase in the volume with time is also being compensated with the amount of volume created when the piston is moving downwards. So the net pressure, which is should have increased, but it is remaining constant because the volume is now compensated by the piston moving down. So the 2 to 3 is a constant pressure process. And this cycle that we have is the diesel cycle. And this diesel cycle will be followed to for a combustion ignition engine. And we will get to know about this diesel cycle in the air standard cycles in the next session. So I have also a video demonstrating how the combustion ignition engine works, and have a look at it.
How four-stroke diesel engines work. Four-stroke diesel engines use four strokes of a piston to complete one combustion cycle. The four strokes are intake stroke. The piston moves down, drawing air into the cylinder via the air intake valves. Compression stroke. The piston moves up, compressing the air within the cylinder. Power stroke. Fuel is injected and the air-fuel mixture ignites due to the increased pressure and temperature within the cylinder. This causes a controlled explosion. The expanding gases force the piston downwards. Exhaust stroke. The piston moves up, forcing the exhaust gases out of the cylinder via the exhaust gas valves. The four strokes repeat themselves over and over again, generating power, then transferring it to the load. Subscribe to our YouTube channel to learn more about engineering.
So that was the working of a combustion ignition engine, a four-stroke combustion ignition engine. But again, the method of ignition and why this pressure is rising, and why how the heat is being transferred into work. So that part remains the same for both four-stroke as well as two-stroke. So so such kind of combustion engine ignition system will remain the same. The method of heat transfer to work will remain the same for two-stroke to four-stroke. So SI and CI, it is independent from four-stroke or two-stroke engine. So we will now learn about two-stroke engines as well. So this is a two-stroke engine wherein only in two strokes, or piston moving up, piston moving down, that is completing the entire cycle of and we are having one working stroke per cycle. So that's the thing, that's the difference. It is completing the cycle in two strokes, whereas in four stroke it is completing the cycle in four stroke. So let us have a look at how this is means how the two-stroke engine are working. So in two-stroke engine, the difference is that, so this is having a spark plug. So this is a spark ignition SI two-stroke engine, right? Two-stroke SI engine. So this part is also the combustible part here will be the air and fuel mixture, not only air. So the air and fuel mixture has somehow to be transferred to this particular region out here. So how it is transferred is that there is a transfer port and there is an inlet valve. So in the inlet valve, actually this valve is responsible for bringing the air fuel mixture down into this cylinder type thing that you can see out here, and this will again move up through the transfer port into this region where the combustion will take place, and this combustible gases will again exit through the exhaust port. So the here the ports are responsible for the whole stroke to take place. So if the question asks, and it's a very generalized question, that whether ports or valves are used in two-stroke engine, then obviously you will select ports, right? Although this is a valve, but still you will use the ports because these are the main functional components out here. And the same goes for four-stroke. In four-stroke, only inlet and exhaust valves are taking means responsible for the entire process. So you will say valves are responsible for in this combustion in four-stroke engine. So if question arises like that, you will answer in this way. So what happens is that uh, initially the piston which is at the bottom dead center will rise up. It will compress the this combustible material out here, and okay, let us first talk about how the combustible material goes down there. So suppose the piston is out at the top dead center. Let us assume it is at the top dead center. When it moves down, then what happens is the air inside this is being now transferred to the transfer port. So as it moves down, at some point, this transfer port will be open, will be exposed to here. And as it is going down, it is pressurizing out here and the valve remaining closed. So it is creating a pressure out here. And this pressure is driving the air fuel mixture into this zone through the transfer port. So as the piston moves down completely, all of the air fuel mixture will come up, and again when it is going up, when the piston goes up, it will cover the transfer port at some time. Eventually it will create pressure. It will generate pressure out here. It is compressing, right? So it is creating the pressure out here, and at the high pressure at the end of the compression stroke, the spark plug will keep produce a spark. It will ignite the entire system. That will create a force into the piston. Again the piston will move down. So that's how the air fuel mixture is first going into this region. Now if you ask me how the air fuel mixture comes to this part in the first place, right? That's an interesting question. So now what happens is that when the transfer port, when it is going up, the piston is moving up, the transfer port is now not exposed. So this would have a constant volume for some time, and when it moves up, the volume here will increase. A sudden increase in the volume is creating a low pressure zone out here, and this low pressure zone is driving the air fuel mixture out here through the valve into this. So this is happening when the piston moves from bottom dead center to the top dead center. So that is bringing the air fuel mixture out here. So piston eventually moves out there, and when it comes down, it is pressurizing the air fuel mixture out here. The valve remaining closed, it has only way to go through this transfer flow to this pipe, and when it is here, the all of the air fuel mixture, finally the piston again moves up. It will compress the air fuel mixture, and create a huge pressure. At this huge pressure, the spark plug will create a spark. It will ignite the whole mixture. It will produce the pressure it is required to produce, and it will push down the piston downwards. So that is happening. Now let us talk about how so by now we know how the air fuel mixture is coming inside, how the air fuel mixture is going to this part through the transport port, but we haven't yet learned how the exhaust port is working. So yeah, the exhaust port actually, uh, so the exhaust port is responsible for taking away the exhaust gases from this region where the combustion has already happened. We know that. So what happens is that now, as the piston is now moving downwards, so the exhaust port is first opened up, because and when the piston comes down, this port will open up, and it is not, the piston is not covering this port, and the gases are now free to move out here. And later on, this transfer port will open up. So you will see the exhaust port is above, transfer port is a little bit downwards, so that first the exhaust gas will move out of the exhaust port, and later on the newer fresher charge will come up, and there is a big hump you can see out here. If you see very carefully, there is a pillar type shape out here. There is a hump in here. That hump is actually responsible for ejecting the exhaust port and directing the fresh charge above. So you will see this is a triangle shape, and due to this triangle shape out here, the air charge mixture will be directed upwards, and when it is directed upward, it will again push the exhaust gases and going down. But again, there is no guarantee, nowhere it is guaranteed that all of the exhausted product will move out of the exhaust port, and only the fresh charge will be combusted into the in the when the combustion occurs. So that case is actually called as the scavenging, because some part of the exhaust gas is still remaining out here with the fresh charge, and that part is already burnt, right? So that is no use when the combustion takes place. That is actually reducing the efficiency. So scavenging, the combustion gases are not removed and are mixed with the unburnt fresh charge, and it reduces the efficiency of the cycle. So in order to avoid scavenging, a hump is given, and hump at the piston is provided to avoid scavenging and easily remove the combustible gases. So this hump directs the fresh charge above, and it pushes the exhaust products through the exhaust port. So that's basically the system, how the two-stroke engine works. And if you are still confused, you can stop me and you can ask questions. Is it clear? Am I audible? Hello.
Sir, yes, sir, audible, sir.
Okay, so I assume that you do not have any questions, but if you have any questions in between, then please stop me and ask at any point of time. You're almost most welcome. So,
Yes, sir. I have a doubt, sir.
okay,
When a battery dead, the spark plug is working or not, sir?
where?
The battery dead, the spark plug is working or not?
Battery dead. So eventually, at the
Sir,
start of the ignition, the spark plug has to work at the some point of time. So if the battery is dead, it will not able to give the spark, right? So it will not able to produce the spark. So the spark will not work. If the ignition system somehow, if you say the piston is somehow moving, the ignition system starts, and somehow the rotation starts and the engine is producing some work, then the battery is automatically recharged. Okay, but at the very start, when the battery is completely dried out, okay, so you cannot start the engine itself, because at the start of the engine you will need the spark plug to work out, right? And that will actually not be helpful for starting the engine. The engine will not start then if the battery is dead. So did I answer your question?
yes, sir.
Okay, okay, thank you. So, the pressure and volume diagram of this two-stroke engine. So basically, what happens is that we are at the end of the, so this is the for only for the top part of the piston. So we are not considering, we are only considering we are considering only the gases which are present in this combustible region. We are not considering the gases which are present out here. So you will see that the suction and this part compression is also changing the pressure and volume out here. So we are not considering that in this diagram. Only we are seeing what happens to this part of the gas. So initially, when it was at the bottom dead center, the piston moving up, above will compress the entire charge, and it will rise the volume like this. And eventually, when it is decreasing, it will expand, and at a certain point, it will the transfer port will be remaining exposed, and few newer charges will go up. So that is basically the release, and you will see a release, a hump like this, and eventually the this cycle is completed. So the compression will happen, and this will ignite, the spark plug will ignite, and it will it will push the piston downwards, and that will expand this, and eventually there is a release of fresh charge into this system, and it will again move to the bottom dead center out here. So that's how it is working, and I have a video which will demonstrate that. So you all have a video demonstration of this.
How two-stroke engines work. Suction stage. As the piston moves downwards, it compresses the air-fuel mixture within the crankcase, and the transfer port is uncovered. As soon as the transfer port is uncovered, the compressed air-fuel mixture flows from the crankcase into the cylinder. The piston then travels upwards and covers the transfer port, whilst also uncovering the crankcase inlet port. Compression stage. The piston continues upwards and covers the exhaust port. The air-fuel mixture within the cylinder is compressed by the piston as it moves upwards. The temperature and pressure within the cylinder increases during this stage. Power stage. Shortly before the piston reaches the top of the cylinder, a spark from a spark plug ignites the air-fuel mixture. Ignition occurs, and a controlled explosion forces the piston back downwards. Exhaust stage. As the piston travels downwards, the exhaust port is uncovered, and exhaust gases are discharged from the cylinder. The transfer port is then uncovered, and the cycle repeats. Subscribe to our YouTube channel to learn more about engineering.
So here the interesting thing is that you see that the exhaust port is above, transport port is a little bit below, and the inlet, this inlet port is out here. Okay, somewhere the inlet valve can be out here, somewhere it can be here, but that doesn't matter, because eventually the this whole piston is driving the air out here, and we are not considering that into this part of the system. We are just needing the air to go in and somehow come to this part, which is happening only through the transport port. So the transport port is a little bit down. So that way, what happens is that when the piston is coming down, first the exhaust gases will be removed, only then the inlet, fresh charge will be made inlet to the whole system. But when it is compressing, so first of all the transfer port will be closed, and then the exhaust port will close. So in that way, there is still some amount of exhaust gases which are present in the system will be pushed out, and eventually the scavenging of the system will be less. So this is how a two-stroke engine, rather a two-stroke spark plug engine will work. So a spark ignition engine will work. And for a two-stroke fuel injection engine or compression ignition engine, that will have a different mechanism. Only the mechanism of ignition will change. Rather, this will remain almost the constant. So next, we try to compare the four-stroke and two-stroke, where the four-stroke is beneficial, where the two strokes are beneficial. So we are having certain aspects, and as per the aspects, we will study about this. We will compare the two-stroke and four-stroke. So first, the four-stroke engine, only one power stroke is present in every four strokes that we have seen, and two revolutions of the crankshaft. So two times it will rotate, it will have one power stroke, but here only one time it will rotate or revolve, it will have a power stroke. So if n revolutions are happening, it will have n by 2 power strokes. If n revolutions are happening, it is having n power strokes. Power produced for the same size as the engine, so lesser power for the same size. So that's a very important thing, lesser power for the same size, as there is one power stroke in two revolution of the shaft, right? So for revolving it two times, only one power stroke is happening. Rather here, each cycle, each revolution is governed by one power strokes. So that way it has more power for the same size. Then valve mechanism, it requires a valve mechanism. It requires a cam arrangement which actually governs the valve opening, inlet valve and exhaust valve opening and closing. So this is a cam which we will be studying later. So again, the cam will be covered in the theory of machines course, not exactly in this particular course, but if required, I will show you here also. Then two-stroke engine, there is no valve, but only a ports. Valves means the inlet valve is present, but that is not very significant. You can have a port, no issue. Then we have the initial cost, the higher initial cost for here, but low initial cost. But runtime cost is quite high in case of two-stroke engine. Then volumetric efficiency, due to more time of induction. So here the time of induction is quite more, and scavenging is not possible. And that's why the fresh charge is always burnt, and a huge amount of charge is burnt out here, huge volume of charge. Accordingly, the volumetric efficiency is quite high, and here the volume which is burnt is quite small. Also, the exhaust products from the previous cycle remains. That's why the fresh charge which is burnt is quite less, and it has low volumetric efficiency. Thermal efficiency, here the thermal efficiency is better here with a better part load efficiency. So part load efficiency meaning, so if you like to operate the vehicle at different load capacities, that is part load. So the engine will have a very good means optimal condition of its operation at a particular speed for a particular load, right? So you will see that 40 kilometer per hour is there is a green signal out there, and above it there all the green signal does not happen. So that is it is utilizing the same amount of very optimal amount of fuel out there. So that is part load. If the load increases, it will eventually have to accommodate the amount of fuel passing through the engine, and that is part load, and it has better part load efficiency. But here, if the load changes, the part loading efficiency is quite less. Then lubrication and cooling. Here, lesser cooling and lubrication required, because obviously you can see it in two
Hello, sir.
revolutions, right?
Sir,
Hello.
why less cooling, sir, in four stroke?
Why?
Why less cooling and lubrication
Yes,
required, sir?
yes, I'm telling about that. So, in two revolutions, you are having one power stroke, but in each revolution, you are having one power stroke. So, in power stroke, what happens? The combustion happens, it ignites, and the heat is being transferred to the cylinder walls, right? And in two revolutions, if one time combustion is happening, so it is transmitting lesser amount of heat to the combustion walls, but here huge amount of heat is means uh, transmitted to the cylinder walls, because every revolution is accompanied with one combustion, right? Here every two revolutions one combustion is happening, so the frequency of combustion in a four-stroke engine is less. Rather, here the frequency of combustion is high, and the combustion is the only way, means factor which is heating up the cylinder walls. So if the combustion here is quite frequent, then we will have to cool it rather very quickly, right? Higher cooling will be required, but here lesser cooling will be required. And why about the lubrication? So lubrication means in a power stroke, you are having quick up and down means actions, and here the quicker up and down actions are happening very frequently, and that is actually creating some amount of friction. And in order to eradicate that friction, you will have to supply a higher amount of lubricants. That way, lubrication and cooling are required less amount in four stroke, whereas high amount in two stroke engine. So, did I answer your question?
Yes, sir.
Okay, thank you. So, next we will work out a few sample problems and end this session. These problems are actually quite theoretical. No, this numerical problems are present for this session. But in the next sessions, I will be solving numerical problems, and I will try to solve it by hand. So that it becomes a more interactive session. So in this session, these are the theory question, and the first question is the function of piston rings. So let us first see what are piston rings. So in an internal combustion engine is which among the above? So a piston ring is basically provided to separate out the piston from the cylinder. If you do not separate out the piston from the cylinder, so this is another arrangement of the piston. So you will see this is the piston ring out here. You will be piston ring out by here. So if the piston ring is not present, the entire surface of the piston will be sliding over the entire surface of the cylinder. That will create a huge amount of wear and tear. And in order to prevent that, we have a piston ring. So which is preventing the piston from wear, right? So that is one thing. And the second thing is it is blocking, or it is sealing the uh, this volume. So the combustible matter at very high pressure, you just imagine very high pressure, it will try to push away and leak out from here. But this piston ring present will prevent this entire thing from leaking. So it is sealing the cylinder, good. And then again, it is dissipating the heat because the piston here is also getting heated up due to this combustion. But there is no means to, transfer the heat to the cylinder wall, because we finally need to transfer the heat to the cylinder wall, which is again cooled down by these cooling fins or by a cooling jacket. So we need to transfer the heat from the piston to the cylinder wall, and that is being done through the piston rings. And hence, the correct answer will be all of the above. Okay. Next, weight of the SI engine is relatively higher than that of the CI engine. So this statement, is it true or is it false? So obviously, the weight of the SI,
False, sir.
yeah, so false. It would be very great if you can interact with in this session, means these questions. So the reason behind is due to the higher compression ratio, the CI engines are made bulky, and so the CI engines are relatively heavier than SI engines. So the statement here is false. Next is, which of the following statement is or are true for the CI engine? There can be multiple correct statements. So if you see, the fuel and air are introduced into the chambers of the CI engine as a gaseous mixture. So in CI engines, is fuel and air introduced or only air introduced into the chamber as a gaseous mixture? So that is CI engine, combustion ignition engine. So in combustion ignition, there will be a presence of a fuel injector that will be introducing the fuel in mist form. That is very small liquid droplets, not even gaseous. So the air and fuel are not introduced into the chamber in gaseous mixture. Only air is introduced. The first statement stands out incorrect. Then CI engine is based on diesel cycle. That is correct. Again, CI engine has a compression ratio between the range of 12 to 20. So CI engine has a huge compression ratio, and this range actually matches. And in SI engine, the range is around 8 to 10. So this statement also is correct. And fourthly, spark plug is necessary to initiate combustion in CI engine. That is not correct. There is no spark plug, but there is only a fuel injector present. So the correct thing will be these two statements. Okay. Then the next question, compression ratio. So we haven't discussed about compression ratio exactly in our session today. So I would like to just give you this view. The compression ratio is basically the clearance volume plus swept volume. That is the entire volume divided by the clearance volume. So if we talk about clearance volume and swept volume, what are these? So in a SI engine, which is where the heat addition is in constant volume, okay, so the piston has to move from this lower position, position 1, to this position 2 out here, and this volume, it is sweeping out, so that's why it is the swept volume. And this amount is kept for clearance, because if there is no clearance, and if there is no clearance, then it will strike at the cylinder head, or it will damage the inlet and exit valves. That's why some amount of clearance is always necessary, and we'll have to clear. But that is actually creating some um, negative effect, because the clearance, if the clearance is not present, the pressure would have gone till up, right? And that way, more amount of work can be transmitted from the heat. But the clearance is necessary, so we'll should not ignore it. And that way, we can define a compression ratio as this clearance volume plus swept volume, that is the total volume divided by the clearance volume. And the clearance volume, wherever it is less, it will have higher compression ratio. Obviously, if it is more less, the clearance is more less, the more it will be compressed, the mixture. So that's why more compression ratio. Similarly, this is the CI engine. So here also clearance and swept volume is present. So this is the formula that you will be using. Then if an engine is classified as a two-stroke engine, then number of working strokes per minute of two-stroke cycle are. So yes, I have explained this in the previous part. So if there are n revolutions in 1 minute, and per revolution we are having one power stroke or one working stroke, that's why n working strokes will be present per minute. So that's why equals the speed of engine in rounds per minute. That is making it quite clear, I think. Then in four-stroke SI engines, the pressure inside the combustion chamber during the suction stroke is, obviously, in order to bring the air inside, you will have to have lesser pressure than the atmospheric pressure. So that's why the answer is below atmospheric pressure. If we have seen in the description before. Then which of the following statements is or are correct? The petrol engine occupies more space than diesel engine for same power output. Thermal efficiency for four-stroke engine is more than the thermal efficiency of two-stroke engine. So the correct answers are these. The petrol engine occupies more space than the diesel engine for same power output. That is not correct, because here we are having the compression ratio is less, and it is less bulky, so that also accompanies with the weight and the space. So for diesel engine we will have to provide more space, and the other statements are correct out here. So the last is, if with increase in cutoff ratio, thermal efficiency of diesel cycle having fixed compression ratio will decrease. Yeah, it's correct. Then sequence of operation stages of a four-stroke engine. This is quite easy. We have already seen that the first is the suction.
Fourth one, sir.
Yeah, first is correct. So first is the suction, then compression, then expansion, then exhaust. This is the sequence. And the last question. So during a suction stroke in a petrol engine, the required proportion of air fuel mixture is supplied with the help of. So I have repeated several times in the video. Would you kindly help me selecting the answer? So suction stroke in a
Carburetor.
petrol. Right, correct. This is the carburetor. So this is all the sample questions for today's session, and you can go. I will upload this video, today's discussion video, in YouTube, in my YouTube channel. It will be shared by the NPTEL committee, and you can refer back anytime and as many time you want. And if you want any other special things to be shown in these sessions, you can comment in this NPTEL website. So there's a ask question part in the NPTEL website. You can directly comment, or you can ask a question. We will be present to answer the questions, and we'll be seeing it quite frequently. May not be each and every day, but in some days we'll see and we'll answer all your queries. And that's all for today. Thank you. And if you have any other questions, we can discuss.